and welcome to another Unity from Scratch tutorial for Unity beginners. In this tutorial I'm going to talk about conditional statements. Now conditional statements are where your programs start become very powerful because it's all about testing for certain conditions in your game and the state of the game and then making the program change direction depending on what's going on. So we're going to start with something really simple. We've got this cube that we've been working with over the past few tutorials, which grows and moves. I'm going to just select the cube and this remove, I already have. So remove the grow and move. We don't need those anymore for this case. And I'm going to move this cube up in the air a little bit. And let's just zoom in on it in the inspector. Okay, so it's above the ground. If we have a look at its position, it's actually 4 above the ground. Let's just lift it up a bit higher. And then let's get the camera to look at it. So select the camera and go Game Object, Align with View. And now we can see where the cube is. Now I'm going to also create a ground plane. So let's just add another 3D object plane into the scene. And it should be located on the ground and at 0, 0, 0. So just in the inspector, set its transform position to 0, 0, 0. Now, if you like, you could make it a little bit bigger in the scene. If you hit R while it's selected, you can actually just drag it out from the center. It's neither here nor there really, because the cube's going to come down and hit it. We're not using a physics for this. We're going to use pure calculations and if statements. And what I want to do is have this cube move down until it reaches 0, which is where we've got this plane situated in the Y direction, and then start to spread out as though it's hit the ground and then it's splat and it's spreading across the surface. And we're going to do that completely with code, no physics whatsoever. Right, so let's begin by creating a new C# file, and let's call it fall in splat. Right, so open up your fall and splat code, and then in the update we're going to move the cube down the screen, and we're going to use, as I said before, code instead of using the gravity. So we'll use the translate function, this dot transform dot translate. We could also modify the Y value by taking a small amount away from the Y position of the actual cube. But translate function basically does the same thing, but you can work in whole vectors. So we're going to use vector 3.up, which is the vector that faces upwards along the Y-axis of the world. And we will multiply that by minus 0.1. F to make sure that it's a float value, which is going to convert what's going on inside this translate function from a vector that's going up to a negative vector which is going down but is only really, really small. So each time we translate, it just moves down a little tiny bit each amount in the Y direction. Right, so put a semicolon on the end and just save it. Now switch back into Unity and make sure you attach that code to the cube. Let me just check. Yep, I've got it there. Right, so when we run it, this cube is going to fall down the screen. Now, we haven't programmed to do anything but move down in the Y direction, so it's just going to keep going and going. And if you have a look over in the transform for the cube, you can see that its Y value keeps getting updated negatively and goes down and down and down. Okay, so the objective we've got now is to figure out when the cube hits the ground, which is when its Y value is 0, and then stop it moving downwards. So we need to do a conditional test on the Y value. And we want to say something like, if the Y value becomes 0, then stop moving. Now this is where our relational operators become very handy, and you might remember these from mathematics that you learnt in high school. So our operators are greater than, less than, greater than or equal to, less than or equal to, and not equal to. And by comparing two values with one of these relational operators in between, we can then end up with a true or a false value. So in this first one of the greater than symbol, we've got x equals y greater than z. Now y is 5 and z is 2, and 5 happens to be greater than 2, which means that x will end up as a true value. So by combining values in our program with a relational operator, we can end up with a true or a false value, which can then be used by an if statement in the code. And the if statement takes your little relational operation and it checks what value it is, whether it's true or false, and then you can direct the way the code goes based on the outcome of the conditional statement that you've just created. So let's just take a really quick look at that to begin with. So back in here, what we want with our cube is that when it reaches 0, then we want it to stop moving. Okay, so let's go back into our for and splat code and let's create our statement. Okay, so the way that you format an if statement is if in little letters and then a bracket, and you put the condition for the if inside it. Now our condition will be around that y value. So if this dot transform dot position dot y is, we're saying, is it equal to 0? Okay, now when we want to check if something's equivalent to a value, we use a double equal sign. You don't put a single equal sign in here, otherwise it's going to put 0 into transform.position.y. And you don't want to do that. You're not setting this value, you're comparing it. So when it's comparison, it's double equals. Now, if the y position equals 0, then we're going to stop moving. So we're actually going to then start doing some kind of a splat thing here. But in this case, we just want to test if it's equal to 0. Now, if it's not equal to 0, so if it's the opposite of what's happening in here, then we put that inside an else statement, also with 2 squiggly brackets. So if what's inside this is true, then the code in here happens. If this turns out to be false, then this down here happens. So if we're not equal to 0, then we want to keep moving down. So I'm just going to move this code down to here. So we're only going to keep applying this translate moving down when y is not equal to 0. So save that. And let's switch back to Unity and have a look what happens. Okay, so let's just check where our cube is. So it's down here and it's still moving. So what happened to our statement? Did it just not work? So let's just go back to the code quickly and have a look what we were doing. So we're taking 0.1 away from the y value every loop. Now we would think that at some point it's going to be equal to 0, but in this case it's not. And the reason why is the starting position of the cube. If we have a look at the cube, it starts in a y position of 7.51. Now, each time we remove 0.1 from that, it's going to get smaller and smaller and smaller, but it's always going to have a factor of 0.01 on the end. So there's going to be this inaccuracy. It's never going to reach 0. It might reach 0.11, and then it takes 1 off it, and then it would be 0.01, and then it takes another 1 off it, and it'll be negative 0.11, and it never goes to 0. It actually skips over being a value of 0. And this is something that can happen quite a lot when you're working in a 3D environment with lots of objects moving around. And that's why it's a really bad idea to test if something actually equals something else exactly, because it very rarely does. There's always some little error value in there. So what I'm going to do is not use this perfect matching condition here. What I'm going to say is if the y position becomes less than or equal to 0, then we will do something else, okay, which we haven't specified. Otherwise, while y is still greater than 0, it will do this bit here, okay? So this down here always gets the opposite condition of what that's testing for. Right, so now we've got this here. Let's just save it and have another go. Okay, so when we run, it's going to go down, and then it's going to stop. And if we click on the cube and just have a look at where it stopped in the y, you can see it's not actually on 0. It's on negative 0.0899. So it's not perfect, and that's fine. Okay, we're not concerned about being perfect. And when you're working with floats and doubles with this amount of decimal point accuracy going on, you can't be concerned with being absolutely perfect. So if possible, don't test for perfect conditions like I am here with this falling. As long as we're close enough, then that's going to do. All right, so the last thing to make this splat function work is to fill in the code that's going to run when we are less than or equal to 0, which is in here. And what we're going to do is increase the scale in the x and the z direction so that it sort of looks like it's spreading out across the surface. Okay, so we can do this with the similar functions that we used last time. So this dot transform dot local scale equals new vector 3, where the new local scale x value will be this dot transform dot local scale. Let's say multiplied by 1.1. The y scale we're not going to do anything with. We'll leave that as 1. And the z scale will be the same as this one here. Actually, this should have an x on it because it's the x part. Then this one, we'll copy and paste it down to here and make that the z part and put a semicolon on the end of that statement. So we're updating the x scale with itself multiplied by 1.1, and we're doing the same with the z. Right, now just before we save this, I'm just going to remember to put the f's on the end of these values. I told you I always forget this. Okay, save it, and let's go back into here. And now we're going to run, and we should see that it falls to the ground, and then when it hits the ground, it starts to spread out like that. Whoa, very fast. So yeah, okay, that's sort of what we're after. If you want a little bit less of a falling down, let's just put a 0 in here and a 0 in there just to make that scaling growth just a little bit smaller. Save it and let's run again. Okay, so you can modify how fast that growth is just by changing that value if you think it's too slow. So you might decide, let's just go back into the code and change it to, say, 1.05 and save it, run that. Yep, so that's a little bit better. And while we're in here, we've got this growth rate here as an actual constant value. Now, one of the nice things about using variables that we've already learnt about a few tutorials ago is that you can set the value for the variable at the top and reuse that over and over again. And then it doesn't matter how many times you might have that particular constant value being used in your program, you only have to change it in one spot. So up the top here, we'll just create float growth rate equals 1.05f. And then wherever we had that 1.05, we can just put that into here. Now, if you were to use growth rate like 100 times throughout your program, you've only got to change it at the top here once, and it's done. Okay, but if you had 1.05 throughout your code in like 100 different places, then you'd have to go and change 1.05 everywhere and find it everywhere. And you couldn't just rely on doing a simple find and replace, because you might have 1.05 in your code as some other particular legitimate value, and you wouldn't want to be editing that as well. So that's where variables come into their own. All right, so we're not actually talking about variables, we're talking about conditional statements. So we've created this conditional statement that falls to the ground and then it spreads out. So let's expand on this if-else statement and add a few more conditions in there, just to give you an idea of how powerful this can be. So back in the fall and splat code, what I want to do in the update function is test for the Y position again of the cube, and we will change the color of it based on its height. Now we can add another if statement underneath this one here, and let's put if this dot transform dot position dot y is greater than 5, then we're going to change its color to red. So that's this dot get component renderer, which is the component that the material belongs to, dot material dot set color, which is a function that we can use to set the material color. Now, how do I know this? It's because I know that there is a thing called material that we've attached to the cube because we created that material, and by looking in the Unity scripting reference, you can find the material. So let's just switch over to that and I'll show you. So in the documentation here, here's our material, and it has a function called set color, which allows us to set the different colors. So we can set the main color, the specular color, the emissive color, or the reflective color of our object. And it gives you an example of the code down here. So we've done this get component renderer, and then we've put the dot material set color on the end, and we're setting the main color because we're using this one here. Now the color value that we're using is this color dot red, which I haven't put in there yet. I'll just go back up here and put this in. So it's going to be double quotes and color. And then after that, color dot red with a semicolon on the end. Right, so back looking in here, this is this color dot red. Now, if we select that, you'll be able to see that there is this color dot red which sets the RGBA values to 1001. But more importantly, we're looking for all the other colors. So selecting on the color structure itself, which is a complex data type, you can see that you can do color dot red, which is what we've done, and you've got color dot black, color dot blue, color dot clear, color dot cyan, color dot gray, color dot green, etc. in there. And so we're just taking advantage of these sort of default settings for the colors in our code. So back in the code here, we've got if the position of our cube is greater than 5, then it's going to turn red. So just save that. Notice also that this if statement is separate to this if statement. So this if statement ends with this bracket here. Okay, so this is all self-contained, which allows us to go into another if statement, which can direct the code elsewhere. So they're not sort of reliant on each other, which is good because we still want it to move down and splat, but now we want it to change color as well. So going back into here, as soon as I run this, if we look at the cube is at position in the Y 7.51 in my code, which is greater than 5, so it should immediately turn red, which it does. Okay, so that if statement is running. Now, if we go back into our code, we might want to change it to a different color if it's at a different height. So we can say else, and we can put another if statement after that. If else if this dot transform dot position dot y is greater than, let's say 3, where this value here has to be less than this value here. Okay, so the reason being is if you put y greater than 8, it's never going to get to this part of the code, because what happens with an else if statement is it's going to check the condition. It'll check this condition. Let's say the cube's at 10. Now 10 would be greater than 5, and it's also greater than 8. But it's going to come into this if statement and go, if this dot transform dot position dot y is greater than 5, which it is because it's 10, it'll do this bit of the code, set it to red, and then because it's done one thing in this if statement, it's just going to skip to the end. Okay, it doesn't check for the next condition or even if there's another condition or another condition. It's just going to do the first one that it finds and then skip straight to the end. That's why if you wanted it to be 8, you'd have to put this as an if statement above this if statement. Okay, I'll let you think about that. In the meantime, I'll come back to here and make this 3 because if it's not greater than 5, let's say it's 4, this part of the if statement will fail, which means it will then test the next case that it has available to it. And because it's 4, it will be greater than 3. Okay, so when it's greater than 3, we're just going to grab this line here and just put a copy in here. And let's make it, in this case, blue. And let's make another if then else. Let's just copy all of that. And we will set this to 1. At which point we will make it, what do you think? Well, let's just set it back to green. Okay, so notice these numbers are in descending order, so that if it fails at 5, it will try 3. If it fails at 3, then we'll then try 1. Let's save it and go back here and run it. All right, so that's working as we would expect it to work. Now, in the case that none of these are true, nothing will happen in this else statement. If you put an else on the end with no condition at all after it, this is like the default. Okay, so if it happens to not be greater than 5, not be greater than 3, not be greater than 1, then we're going to do this. Now, if we set this color here, it's going to be interesting, so that once it falls below 1, it will then trigger this default part of the code. So if we make this yellow, save it, and now switch back and run. So the very last thing it does, once it is no longer greater than 1, it will go to yellow. Now in here we could say if else if this dot transform dot position dot y is less than or equal to 1, which is the opposite condition of this. But we already know that it must be less than or equal to 1 if it even gets into this part of the code, because it doesn't meet any of these criteria. So it has to have fallen below 1, in which case it will satisfy this. And that means we don't need to test it. We could test it, but it's just a bit of waste of logic processing, which is, I guess, pretty negligible, but you don't need it. So this has got to be less than or equal to 1 by the time it actually makes this true. Right, so that's an if statement, an if-else statement, and an if-else-if statement. And they're conditional statements using a single relational operator in here. And you can use greater than, less than, is equal to, and all of those ones that we looked at right at the beginning of this tutorial. All right, so I'll leave it there. And then in the next tutorial, we will look at some more advanced logic statements that you can use inside of the conditional statements. Okay, thanks for listening, and I will talk to you in the next tutorial.